All right, just waiting to see myself pop up on the screen here. Is my video? Oh, my video is not showing, that's why. All right, I would like to welcome everybody to our second virtual Vancouver hardware meetup. Today is welcoming our Robotic Overlords Part 2. I'm just going to open up some slides here to welcome everybody to the event. All right, and first I gotta start sharing my screen. I appreciate in advance any patience you guys have with any technical difficulties we have today, because when you're doing things over the internet and going live, just about anything can happen. All right, and is my screen sharing? I don't see anything. Can somebody in our meeting confirm that my screen is indeed sharing?
Yes, we can see your screen, Madison.
Okay, and you can see the presentation?
Yes, we can.
Okay, perfect. Vancouver Hardware Meetup is a quarterly speaker series and networking event organized by MistyWest. MistyWest is an early stage based in Vancouver who specializes in sensor development and embedded chip devices. About Vancouver hardware meetups, we are a forum for local hardware developers, product developers, engineers, makers, entrepreneurs, and funding angels to pull together their minds from all corners of the hardware community in Vancouver to help connect makers to funders. We did a previous Robotic Overlords event in September 2018 that was really well received. Back in November, we did an event that was dedicated to evolving 3D printing technologies, where we had a panel of experts in various different 3D printing industries come to the event to just talk on the topics. And this past September, we did technology for conservation, how technology is helping us understand and protect the natural world. And so it was a bit of an intersection of people that were working with startup accelerators to somebody working for that was representing the Nature Conservancy of Canada, just to get an idea of what we can really look forward to and what we can work towards to building more sustainability throughout the planet through technology. I would just like to give a code of conduct for everybody that's joining us. We are committed to providing a harassment-free experience for everyone at our events, regardless of gender, gender identity and expression, sexual orientation, disability, physical appearance, body size, race, age, or religion. So any comments in our live chat of a harassing nature will not be tolerated, and anyone violating these rules will be removed from the discussion. So today's event is welcoming our Robotic Overlords Part 2, now with 100% more computer vision. We are going to be focusing our conversations more on the computer vision aspect of machine learning and AI. We've partnered with Microsoft Garage for this event, so we're very excited about this because this has kind of given us a new opportunity to expand our viewers and expand our reach. And I would like to introduce you to our panelists. I'm just going to go through the list of names here and hopefully not completely botch some names in here. And once I'm done, I'll give everybody an opportunity to introduce themselves. So we have Andreas Putz. Andreas is a computer scientist here at MistyWest. Ritesh Rohit Mittal, software developer at Microsoft. Ayal Anav from Intelligent Video Analytics and at NVIDIA. And just so you know, he's actually joining us from Israel, so it is quite late over on his end, but he is so kind to still be joining us. We have Edgar Collins, technical director at SRI International, and Les Karpas, who is the president and co-founder of Lexet AI. And moderating today's discussion is Justin Gerard. Justin is a data scientist at MistyWest, the CTO of Pax Financial. I believe he has a master's in machine learning, if I'm not incorrect, and so he can give a proper introduction to himself in a couple of seconds. And just to give you a brief note on today's agenda for the event, We're going to be starting with a 10-minute presentation from Les. It's on better data for better vision. There will be a 45-minute panel discussion moderated by Justin, followed by a 30-minute Q&A from the live chat. So if you have any questions, please feel free to drop them into the live chat. We will pick them up and we will get back to your questions when we get around to the Q&A. And then the last, whatever time we have remaining at the end of the event, we'll just do some announcements and anything about upcoming events. And to give you a sample of some of the questions that we're going to be asking today, you can get an idea. What are some market trends to be aware of in embedded vision? How do you plan your data pipeline? And what's in your secret toolbox? I personally always like questions that are a little bit more on like the ethics and morals of robotics. So I want to encourage people to just drop some comments or some questions like that into the live chat if you're interested. And that is it. So let's begin the actual introductions to each panelist, and we can just get the show on the road. So thanks, guys. I'm going to stop sharing my screen. All right. If we can go to the, Justin, you're in the top left. I'm going to mute myself from here on out, and you guys can all start giving your introductions.
Sure. So I suppose welcome everyone, and I suppose maybe just starting from left to right intro. So I'll let Andreas sort of with the A there start off the process.
Okay, I'm Andreas Putz. I'm the mathematician at MistyWest. Have been with MistyWest for about 3 years, and basically as one of the few non-engineers, technical members, everything which has to do with computer vision, data science, physics and math, sooner or later lands on my desk. And our focus in the last year or two has been shifting towards intelligent devices. So in the broader sense, IoT devices, but with a spin. And that spin is typically a computer vision application or some other novel sensor integration on a device which has internet capability. And that has some challenges for us. On small devices, simply getting a network connection which is stable up and running is a challenge. Power is always a challenge. But also if you have a vision system, embedding a vision system in environments which are not straightforward is quite a task. And so we spend a lot of our time tackling data quality, tackling the pure hardware problems before it even hits the machine learning. And then if it finally ends up with me, I'm trying to add some machine learning and some data science on top of that. And that's roughly what I do for MistyWest.
Sounds good. Next up, Ritesh, do you want to tell us something about yourself?
Hey guys, I'm Ritesh Mittal. I basically am a developer in Microsoft. I work in Office 365. I've been working with Microsoft for 8 years, and I've been in Office for 5 years. However, I have I'm very passionate about AI as well as robotics. And in the 8 years which I've been in Microsoft, I've been trying to basically use side projects to basically like in terms of hackathons which we have inside our companies to basically use the power of AI to and also leverage our technologies to ensure that we make the world a better place to live in. So yeah, I mean, this is my introduction.
Good. That's perfect. I think side projects are always a really critical activity for any sort of developer professional. Ayal, is it Ayal? Am I saying that correctly?
It's actually Eyal.
Ayal, thank you. Take it away.
So I'm Eyal. I'm IVA. It's Intelligent Video Analytics Developer Relations in NVIDIA. My job is to help startups, companies, any developer that is doing video analytics. Of course, it's involved with today with the intelligent AI, inference, segmentation, classification. It's a bit complex due to video and audio relations. And so I'm 10 years I have 10 years of experience in the video, worked in the harmonic video systems, if you know, 2 startups doing an AI. And I'm happy to be here to discuss this, the robots future. Yeah.
That's perfect. Perfect. Edgar, how about a quick intro?
Come again?
Oh, sorry. It's Edgar up now.
Yeah. Hello, everyone. Great to be here today. My name is Edgar Collins. I am a technical director at SRI International. SRI is a not-for-profit R&D institute that was founded by City some 70 years ago. A team of multidisciplinary scientists, literally from anatomy to zoology. We perform basic and applied research for a lot of U.S. government agencies, DARPA, NIH, Department of Education, NASA, and others. Also commercialize a large portion of our intellectual property through collaborations with multinational companies, but also startups. Some of our most notable startups have become household names. Siri was an SRI startup before it got onto the iPhone and all Apple products. Nuance Communications, Intuitive Surgical. My role is I lead advanced R&D projects, particularly in the machine learning space, bridges speech, natural language, computer vision, and oftentimes the fusion of those multiple modalities. And so my focus is working with companies to transition and license our technology towards productization. Great to be here today.
That's great. That's quite the gap to fill as well. So bridging research to commercialization is no joke. Yeah. So how about you, Les? What are you working on?
So let's see. I'm a serial entrepreneur in the 3D space. I started working with MistyWest in 2013 as a part of my last startup, which was a 3D printed medical device company. I had invented a method to print medical grade silicone, and we were doing scan to fit respiratory masks. When the bubble burst in the 3D printing space, I got recruited by a research lab in Seattle called Intellectual Ventures, and they tasked me as an entrepreneur in residence to take some of their IP and turn it into a company. Lexset is the company that resulted, and we spun out as our own subsidiary. And what we do is we create synthetic training data to teach computer vision models more effectively. And I have a presentation I'm about to give where I can get more into the details of that.
It's perfect. Yeah, that sounds very exciting. Yeah. So for myself, just to finish off, I'm Justin Gerard. A little bit of a serial entrepreneur, I guess. That seems to be what's going on. I did my master's in aerospace robotics, specifically in the area of knowledge representation. Looked a lot into multi-agent reinforcement learning and knowledge transfer between human participants and robot automated agents in real time. So that bridged into business, which acquires some of the intellectual property called Fleet Ops, which does the logistics management, so recommendation of freight and matching problems and optimization of routes. And then recently, I've been working on a second project, Pax Financial. So we've been in this sort of stealth technology incubation phase with a couple of partners for about 12 months now, and it's been a lot of fun. But yeah, we're just nearing our sort of first launch. So as these things go, it's a fun sprint. Yeah. Yeah, so that's it for that. I guess at this point we're moving on to, is this straight into the Q&A? Or we're doing the presentation, I believe, Les. Is that the next on the agenda?
I think I'm doing a short presentation on sort of the basics of computer vision for the uninitiated. Correct.
That is what's next.
Yeah.
Okay, perfect. So I guess without further ado, I'll let you take it away.
Should I screen share? And can everybody see that successfully?
Yes.
Great. So I'm going to give a quick overview on what is computer vision, what are some of its business applications, how does it work, and a short little bit about Lexet and how we're making it easier for others to execute. So first, what are business applications of computer vision? Where is it making money, and what's interesting about that? So there are robots called inventory robots or planogram compliance robots that go up and down the shelves of big box retailers, making sure that everything is in the right place and keeping track of what all the objects are to know when things need to be restocked. Then there are service robotics, like robot vacuum cleaners, that navigate your home and might spend more time in front of a couch than they would in open space because that area gets more foot traffic because the robot's able to recognize that that's like a high traffic area. Then there are fulfillment robots that grab things off of shelves to pack boxes, like in Amazon warehouses and similar. And then last, but most commonly known as cashierless checkout, which is getting very popularized by things like Amazon Go, and 7-Eleven has a cashierless checkout solution that they're going to be coming out with later this year. And so that's kind of some of the robotics use cases for computer vision. Then there's a whole separate world of mixed reality use cases, providing additional information to people about products on shelves as they're walking in a store, or creating a holographic friend that can navigate the environment around you, sit in actual chairs even though they're not actually there. Being able to do wayfinding or part recognition in industrial use cases where you need to know what something is, or where do you put something away, or something's broken and you need a new one. Or visual search for retail, like what does this product look like and how do I find other products that look like it? So now let's do a quick overview of how computer vision works. And on the very, very basic level, computer vision systems do a couple of single object tasks. So image classification is sort of the basis of most computer vision. That's, like what is in this image? And in this case, it's a cat. Then you have nuanced classification or deep classification, where it's what is in this image with a series of descriptors that get more and more detailed. Like this is an orange and white Maine Coon kitten. That'd be a deep classification for this. Or classification with localization, which is what is this thing in the image and where is it located in the image? Then on a more complex level, when we start to combine those things, we get to multi-object functions of computer vision. And so generally speaking, object detection is one of those things. So what are each one of these animals and what percentage likelihood is each one of them the thing that we think it is? Then there's what's called semantic segmentation, which is let's trace each one of these objects so that we understand their boundaries. And then instance segmentation, which is not just the boundaries of each object, but keeping track that that's cat number 1, that's cat number 2, that's duck number 1, that's puppy number 1. And so if there are lots and lots of things in a scene, that we can keep track of all of them, where they go. So now let's talk about how computer vision works. And there's a concept called a convolutional neural network that is at the heart of the majority of computer vision tasks. And that is different ways of looking at the pixels in an image and kind of analyzing them, grouping them, and clustering them so that we can do pattern recognition tasks. And what a CNN looks like or behaves like is this different series of ways to break down the image into what are known as features that can be then extracted and analyzed so that you can say that, you're looking for, whiskers and pointy ears. And if those things exist, they're probably looking at a cat. And I'm oversimplifying a little bit, but that's basically how most computer vision systems work, is some flavor of that activity. And so to train a computer vision system, what you have to do is you have to get lots and lots of photos, either from an existing library or from a photographer who you pay to go around taking pictures. Then the big dirty secret in AI is that you need all of that content labeled. And so you have to pay a labeling service to go through the data set that you've just acquired and manually label things so the computer vision system can later automatically label things. Then you train your AI, you feed all of those images into that neural network that we just kind of talked about. And what you end up with is something that performs most of the time the way you want, but not all of the time. And then you start the process over, adding new data to the system to try to get it to tweak in the right ways. This process is sort of unfortunately rife with a handful of problematic issues. So first off, collecting photos takes a long time. That's annoying. Second, people who are labeling the data make mistakes, and so you get a garbage in, garbage out problem with how a neural network is trained. And so like that's quite harmful to it. And then you have what's called data bias. And data bias happens in explicit and explicit ways where the camera angles in all of the shots might be the same, or the height off the, like, because the human, and so he was taking pictures from 4 to 6 feet off the ground. Maybe he used the same camera to take all of the photos. So the actual chip that was taking the pictures has the same kind of noise. Or maybe he was just drawn to certain kinds of subject matter, and that caused him to leave out other kinds of subject matter, and that causes its own form of data bias. And then people tend to take photographs in good lighting conditions, and so you end up not having photos of bad lighting conditions, and that further compromises an AI's performance. So to solve this at Lexa, what we've done is we've created an engine that virtually creates thousands and thousands of scenes with various configurations based on rules that we feed the system. So we can create as much content as we want at will within certain boundary conditions. And this means that we can train the model much more quickly, and more importantly, see what the holes in that model are so that we can create new edge conditions very rapidly to really shorten that cycle time down. And so the benefits of this are being able to reduce the bias, being able to ensure that all of the labels are 100% accurate, and being able to get a lot more data for a lot less money, which is generally speaking a great way to get AI to perform better. And so what it kind of looks like in practice is this is an environment that our algorithm put together, and then the annotation as rendering pipelines. And so they're instantaneous and they're perfectly accurate. So instead of paying someone to slowly trace all of the objects in a scene, we can just pop that out automatically. We can also do things like depth information, which is really key in robotics use cases. Or we can, physically accurately render the space so that we're capturing all of the reflections and refractions correctly, which ends up being super important for getting AI to accept a rendering as real life. And so that's sort of the high level of what we do at Lexet in your 10-minute overview of computer vision. And the takeaway from our standpoint is we're trying to make infinite data for everyone so everyone can do whatever they can think of wanting to do with computer vision training. So that's going to conclude my short presentation on that.
Those seem to be indoor environments. Question. What sort, do you also do outdoor environments for navigation and things like that, or are you mostly, what kind of problems are you mostly focused on?
As a team, we kind of strategically decided to be very focused on interior space and object recognition. There are a lot of companies trying to solve the autonomous car problem of procedurally generated outdoor environments. And that is incredibly processor intensive, and there's like a lot of resources being thrown into that. And so we just decided
as well, I suspect.
Yeah. And so instead of playing in that red ocean, we decided to, go the road less traveled and really focus on industrial use cases, service robotics use cases, and mixed reality use cases.
That's good. Yeah, good strategy. Perfect. So I suppose at this point we're around the time, actually right on schedule to jump into the Q&A. So if you guys are ready, I have a few questions to shoot at you. I think the way we can do this, if you guys are up for it, I don't know how this has been done in the past, but maybe feel free to chime in if you have something to say, and then I'll call time if we're getting close. But the first question, which is sufficiently broad and fun, is what are some of the major market trends that we should be aware of in embedded vision or even in computer vision in general? So what should we be thinking about stepping into the future?
Yeah, so can I talk?
Yeah, please.
Am I allowed? Okay. So
anyone can jump in, and then if you start fighting too much, I'll jump in.
Yeah, so there are many agendas. What I can say from what I'm seeing in my position is that There's a sensor-driven AI. There is a solution-driven AI. What's happening now is that the hardware and the algorithms really bring the AI to a point that you can do sensor fusion of algorithms that are already existing and get much better accuracy and precision in tasks that were based on a single sensor did not work very well, especially in robotics. So this happens with the audio, combination of audio and video, LiDAR, all this sensor fusion, which comes actually from autonomous cars. It didn't work so well so far, right? The autonomous cars is not really there, but all this technology is coming down to smaller robots, smaller cars with the much less challenges than the autonomous cars. So I think we're benefiting now from this challenge of autonomous cars for robotics. That's what I'm thinking. So it's if I can say, there's Jarvis from NVIDIA. There's a sensor fusion framework, but I will not drill down on it right now. And yeah, that's it for my part.
So more on that idea about market trends in embedded vision. Does anyone else want to jump in?
Yeah, from
I can jump in. Oh, sorry, Andreas.
No, go ahead.
Great. So one area that I think is similar to the comments earlier is we're seeing a need in factory logistics of embedded computer vision. So we have customers that are working in environments that are not internet connected, and they need to have these autonomous vehicles travel around, factory floors. And so they use computer vision for navigational purposes, which of course can get tricky because all of a sudden there's a pile of lumber there that wasn't there yesterday. And the device needs to understand what that is and it's something to be avoided, or humans walking toward it, etc. So that's a really fun area. I think it's ripe for growth as more and more logistics centers are automated, and having these vehicles that can autonomously get around and use computer vision to do that in different lighting situations. At night when the lights are off. Is a real fun challenge that we're working on at SRI.
That's perfect. Yeah, I'd imagine in disconnected environments, if you have an embedded system, then being able to train and update models locally is critical in that situation.
Or in simulation. You should do it in the simulation.
Yeah, so I mean, along those lines, we've been doing some pretty neat stuff with Verizon. We were one of the winners of their Built on 5G challenge. And so we've been playing with them on designing systems where we can simulate data on site and then train the model on site, and then using what they're calling fog computing or mech-based computing, stream the trained AI model to all the devices in the industrial setting. And so 5G is going to usher in a lot of cool stuff on that front.
That's perfect.
I agree. From MistyWest's perspective, I think now for the last 1 or 2 years or 3 years, there are some compute platforms you can actually easily integrate on the edge, and really has opened up edge computing and edge inference specifically for smaller companies and integrate the solutions. And like NVIDIA has the Jetson family with TX2, which you can pop the SOM off. I managed this well. Yeah. And
TX2 is kind of old. There's now the NX, the Xavier, but not that now.
Yeah. So, and you have this now in different power levels and different sizes and different companies. Google has their own version of it, and you have the market, I think, stratifying between ultra low power applications. So where the battery power is very, very restricted, you can do very little, But already on these small devices, you can run an inference model which can wake the main CPU up and trigger certain events. And then I think you have a lot of, with computer vision, I think the privacy aspect of a role going forward. And you see the big companies reacting. Azure and Amazon have pulled their facial recognition software for the access of the. So there seems to be a lot of conscience coming in that, hey, streaming all that personal data to a cloud service, which then does whatever it needs to do with it, is perhaps not that good idea. And I think this will drive a lot of the edge compute and doing inference locally, but not streaming it off the device. To the extent that we have.
That's an interesting
efforts on the efforts on the reduction, like taking the video stream and just taking the face off, blurring it in real time. We actually have a deep stream example of that in Python, but it's another topic.
Yeah, that has implications in healthcare too, right? Where you could imagine a lot of sensitive healthcare information that's image-based that can be collected at the edge, processed at the edge, and only the insights, travel to the cloud.
Right.
That's
exactly.
Actually,
and
I was just going to say that's one of the that comes up a lot is of things for medical data, but that's much harder to do, and so I don't think we're quite there.
Heads up, you lost audio on mixer feed.
Oh, can you hear me now?
Yeah, on Teams it works. I can hear everyone. So I think, Chris, this is something you have to work out. That says.
I think it's everything's okay for us. Is it okay through the front end?
Heard a that's better response on the chat.
Okay, perfect. Makes it just us. No, I'm kidding.
I also want to kind of add to the discussion, right? So basically, with respect to the healthcare systems that we're talking about, right? So I can definitely say because of the current situation we are currently in, which is COVID-19, being as a catalyst for companies to basically use their AI power to diseases like COVID-19 and basically kind of go from there. So I feel like that is also one of the upcoming trend wherein we'll see that like more and more power of AI would be utilized.
Natural progression that as people begin to value privacy more, that we would want server devices to move locally so we could have leverage over those systems. For businesses, so you don't have to pay for the cloud. So there's several advantages. So it seems to make sense. These are really interesting points. Does anyone have any more questions or comments about the market trends before we move on to?
I also want to kind of add to this there's trends which are coming on in like consumer spaces as well. You can see that seeing the other day, like in Amazon, like there's a toy called Anchor, right? And like they've embedded vision to kind of, just so I can see that a lot of AI, to basically come in. So these were.
So
one thing I'd like to add, another small thing is that just the topic of retail, robotics in retail. I think it's going to be big because they're already this week I've been in a without a human being. There was like a talking. I think the next thing is really, like a robot that talks to you and does the suggestion and everything with the natural language items. I think for the robots, and it's not too much. There's no risk there, you know, not too much risk. It's not autonomous cars.
Yeah.
They don't get COVID.
Yeah.
If you touch it, you know, it's
Definitely, I could definitely see the automation kind of taking in like different sectors, like manufacturing, you know, like, I mean, you know, definitely I can see that, you know, these trends coming up, especially because we are working remotely and because of the situation which has impacted, like, so I think these trends are definitely I can see picking up in the industries.
So if you think forward 5 or 10 years, if we had to like together right now paint a picture of what society looks like in 5 or 10 years, what are some of the things we would see walking around? Like, what are we looking at? And this is completely hypothetical, of course.
Well, I think you're going to see
one of the areas in. I'm sorry. Go ahead.
Yeah, go ahead.
Robotics. So one of the areas I think is very fascinating, and it's still a very nascent field, is for robots powered by computer vision to understand human state, right? So what's our emotional state? Not just whether our to figure out, but are we confused? Are we angry? Are we injured? These are all very important things. And then for a robot adapt to that situation, understand our gestures, which are also different for different cultures. So I see a lot of progress in this area, made by many places, including SRI. And I think that's going to be essential for humans to really start, collaborating with humans, as opposed to a robot doing something and then the human does something, but actually working together on things. I think that's a very necessary capability that we see coming.
What I was going to add is that I think we're going to see spatial computing become a thing instead of a concept, which means mixed reality systems or other app-based systems to help you prepare a meal or fix your car when it breaks or build something you didn't know how to build. There are lots of things that right now computers just can't do because they can't perceive the space and environment that we live in. And that's everything from like, how do I interior design this room so the feng shui is better, to like, where should I how should I like adjust my car for one reason or another? And right now, like, computers are ignorant of how to do that, but with really good object recognition and telepresence, lots of very neat things become possible quite quickly.
I want to add to this. You're completely correct, Les, and I can see that happening in our industries as well. And I also see that companies basically putting in their APIs. Like for example, Microsoft has Azure Cognitive Services APIs for object recognition, so that people don't start from scratch on building their models, but to use services. Like as a service, you use their APIs and kind of go from there. So I see that companies exposing their services to enable more and more use cases for AI as a trend is one of the biggest trends in the future.
Right. I kind of I just made up a moment ago. About. Do you guys have any thoughts about interacting? Sort of idea, but it's kind of.
I'm seeing in the quote unquote transfer learning space that I'm seeing progress.
Of course, yeah.
I've seen a lot of
It's
people wish great things would happen there, but I haven't seen anybody
you can train on tests and you won't succeed.
Right.
So physics, the universe is not letting us escape unless you render it in such a way that the universe doesn't matter. But of course, you can do simulated environments, but the key concept, your simulation has to be right enough. There is only
real-time ray tracing, which is, more
it cannot be real-time.
we discussed.
But Justin, one of the standing context, I think this also points out one of the problems that we're in. I mean, today everybody's so reliant on DNNs, and DNNs are going to solve everything, but DNNs are still statistical, right? And we've kind of jettisoned the whole, rules-based methodology in AI as being kind of old school. And now there's this need for what's called explainable AI, which I'm sure the other panelists have heard about. And so we go back to the example of the cat that Les was showing. Like, the DNN can very, with high accuracy classify that that's a cat, but you can't ask it why it's a cat, right? You can ask a 2-year-old and they'll say, well, it's got whiskers, it's got pointy ears, of course it's a cat. But the DNN can't produce that kind of human-based explanation. So I think as Justin was saying, these different contexts, we need to have some kind of merging of a rules-based system with systems that kind of seamlessly play off of each other. And I think that's still a very nascent area of research in AI.
Yeah, I agree.
And I agree with that. And there are revenues to do that. Like when you said with explainable system, a lot of the approaches are seen as still pure post-processing. You run your network as you normally would, and then post-processing tells us what feature of the input vector it actually took to arrive at the conclusion. But the way we built our networks was still basically based on social data until neural networks came along and convolution layers came around. That has a little bit of a physical intuition into it. But the rest removed all physical intuition. I think there is space for moving it back in.
There are networks that take the context and get you the picture and vice versa, and there is some progress there. And the easy way to get it there, I think, is using something like Jarvis that takes audio, text, and video, and does the fusion of all these aspects together. Again, with the context, with the context of the actual or text. Yeah.
But there are still very basic things computer vision has a trouble, like CNNs have issues with rotation. Like we are translational and scaling invariant, we are not rotation invariant. Our brain has no issue with recognizing a face that it's a face, if it's upside down, angled 30 degrees or not. CNNs, you have to train with image data in all possible rotation, which comes back if you have a photographer running around the street taking photographs, you're not going to turn your camera.
There's that famous example.
It's doable.
Andreas, was that famous example you probably heard of. It's from autonomous cars where you have a picture. It'd be better if I could show you on screen, but it's a picture of a stop sign where someone's put black tape on it that kind of looks a little bit like a 4. A very famous example that the car misinterpreted that as speed limit 45 as opposed to a stop sign. So with very kind of minor changes like that, a human would immediately know that it's a stop sign with tape on it. The computer vision system, mistook it go 45 as opposed to stopping the vehicle.
Yeah.
So there's lots of examples like
in there.
Actually, so what I will say is I've been reading a lot of the papers that have been coming out of CVPR this week. And a few of them, I've seen some really interesting stuff about interpolating feature identification on one 3D object to another similar 3D object. Like in one of the papers, there's an example of a horse and a dog, and the AI the user points to the nose of the horse, and then the AI can interpolate that that's also the nose of the dog. by doing like a whole bunch of different mesh deformations, they can apply the same spatial logic to one shape to a similar but different shape. And like, so we are seeing some neat advances on that front.
Totally.
It's feature matching.
We dive into, so we should
neural network as a domain.
Perfect.
Okay.
So let's jump into let's talk more turkey about the actual basic steps to train models and to move things into production. So if for anyone who wants to speak to this, when you're considering beginning a computer vision project, and you're looking at things as practical as software libraries or theoretical considerations, data analysis. What are some of your first steps in analyzing a computer vision problem?
I wanted to go first here because before the experts speak, I wanted to basically just put in my points. So basically, before I speak of my computer vision projects, I first understand the use case on exactly what I want to solve, like what exactly would be the use case, so that I understand my data, like exactly what kind of data I will be fetching from what sources. And then from there, I understand the data classifications or the pre-existing models which I can use to basically classify, transform data, and then from there basically go forward. So those are my initial first steps, which I basically do before I start.
Perfect.
Yeah, I agree. The data is the important first thing when you go to a computer vision problem. You need to gather data, and you need to verify you're collecting it correctly for the goal you're looking at. And actually, this can change throughout the process. Totally. You might start with 2 cameras, go to 6 cameras. Change frame rate, change the lighting. You find out that lighting that just breaks everything.
Yeah.
So I actually really I'm such a big nerd when it came to the autonomous robotics work I was doing. I was such a big nerd about the about modifying the data set and generating new parameters. But I'm just curious, what are some of the little tricks you would use when considering data feeds when it comes to, say, image processing or pre-processing? So you're considering this first step where you're gathering data, you know your user problem. What are some of these like filters, or how are you going to pump out some interesting features? Like what do you find works well in your experience?
I actually go to step -1, and step -2 is, I guess, the use case, which I forgot in my listing when I wrote the list this morning, to my shame. But step -1 is the optics. The optics and the light. The light has a catastrophic event, even if the optics is perfect. And Edgar and I have worked with things, the optics works, and then you put into a different light environment, and you look at what comes out, and you think, oh my God, what have we done?
Yeah, 1,000%. Like our first step approaching any project is, what is the camera this AI is going to be deployed on? And what do we need to know about that camera? Its focal length, its depth of field, the camera angle, the kind of noise that comes out of the chip, the resolution, and like start there.
Yep. All the gains.
And
right.
then
like data variety becomes really, really important, right? So oftentimes, you can't predict the camera target system. Sometimes you can, but when you can't, you need to have that variety of data. So if somebody wants you to recognize, different kinds of cars in a real-time autonomous system, and they just give you, images of showroom vehicles, you're not going to do it. So you need to have, especially outdoors, right, where we have different lighting conditions, different weather conditions. Snow on the back of a truck, it's still a truck. And that makes it really, really hard, is just in some of the things that we've worked on, is getting the right variety of data. It's not even just about the volume, it's just the variety of data that is similar to the target runtime system is a real challenge.
And variety and unbiased, because as Les, you said in your presentation that the model is biased, but the model is not biased because the CNN is inherently biased. It's because you fed it biased data. So the model, if you want to produce the best model possible on biased data has to be biased.
that's like why we started Lexet. We didn't set out to build a synthetic data company. We were actually doing something totally different. And it was in the process of doing that other thing that we built this tool for ourselves to make the synthetic data. And then we were like, wait a second, everybody else needs this too.
Yeah. So now there's legislation coming in and saying, okay, if you have to produce unbiased predictions in your inference engine, but you don't have unbiased data, you don't know. Sometimes privacy requirements don't allow you to test whether your data is biased in the first place. So you have no idea that your data is biased, yet your algorithm has to produce an unbiased outcome. That means you have to bake your algorithm somehow, and that's still very much in its infancy. Mm-hmm. I think we detoured a little bit from our pipeline.
No, this is perfect.
I was going to add that another real challenge in the data pipeline that we've seen is the correct labeling of data. So if you have a classification problem where you have, multiple classes and it's not just, is it a cat or not? You really need, some human experts, and sometimes those are hard to come by depending on what kind of data you're talking about. And we worked on one project recently where even human experts, physicians, disagreed on the labeling of data. So what do you do there, right? So you do a 2 out of 3 voting. It's really a tough problem, and the CNN's only going to be as good as it is if you have correct labeling of data. So that's another issue in the pipeline is who labels your data and how good are they at labeling it.
Definitely.
This adds to the
we're kind of running out of time on this one, but I want to sneak in a personal little question about this. So I deal with a lot of non-stationary data sets and finance, as one might expect, because literally anything you train on will be gone in a few months. So is that a concern for computer viz problems, that the data sets you train on can vary over time? Or I imagine, there might be new kinds of TV sets, new kinds of coffee makers, et cetera, et cetera, et cetera. And if so, if you do consider that, what are some of the strategies that you think of to deal with models trained on non-stationary data sets?
So I can tell you this anecdote. One of our robot vacuum cleaner clients shipped their robot to a new part of the world where they hadn't been operating before.
Exactly. Yeah.
And what had been working fine in the United States did not work at all in this 100%. Region. And so they were like, okay, we need you guys to generate images of these textiles, these rug types, these furniture types, now. To adapt to the region that they had no data on.
Right. Interesting. So I think that's an interesting kind of back of the head question, dealing with drift and sample sets, and how do you even, that's an interesting problem.
We've seen that challenge.
So go ahead, Edgar.
So we've seen that challenge in logistics operations of consumer goods, right, where the consumer goods are changing all the time. And there we actually did employ some transfer learning to help. Cool. So, like a box, a cylinder print change that much, it may have a different color label, but it's still a can of Pringles. But anyways, that is I think a real problem, Justin, that you pointed out, that, the objects are changing nature all the time. That's going to continue to grow, not dissipate.
Right.
Go ahead.
For independent devices, this will make.
So I have to. Oh, sorry. Go on, Andreas.
So for autonomous devices and independent devices, this makes maintenance and updates crucial, that you have a pipeline which can deploy and update the models locally in a way which is secure.
Extremely good segue. So do you want to comment on, that's actually the next sort of topic. So maybe Andreas, you want to speak to planning a data pipeline and for computer vision and what that process can look like. If someone's looking at, you have your data set, you've considered a lot of these factors, you want to consider pumping out new models, new experiments. What are some things to consider?
Yeah, so one of the big movers in the last 2-3 years, I would say, is localized Docker containers on these hardware infrastructures. So you can now run Docker almost natively on, for example, the NVIDIA TX2s with native access to the hardware. And the one there is that switching your entire inference engine out just consists out of updating your Docker container. And most big cloud providers have a service for that. So for Azure, it's called IoT Edge. For AWS, it's called Greengrass. I have no idea what it's called for Google, but they have a service as well. But basically, they have a client running on your infrastructure. And then if you release a new model on your cloud infrastructure, it will download the Docker container and will check that the Docker container comes up, and then your new inference engine is up and running. Yeah, and then if you do the encryption keys correctly.
Right, there's an actual example with the webinar from Microsoft that from Paul DiCarlo, if you know. So yep. He's showing how he's deploying DeepStream, changing the model on the fly. So this is great for production, for the smart city when you have.
Yeah. And the other nice thing is you don't actually have to work on the TX2. You can actually train in your cloud environment, train your model, and then you transfer the model onto simulated hardware in the cloud. And you do pruning of a network, you cook down the accuracy of the representation, you check if the model is still as accurate as it was before, have a Docker image built in the cloud which is optimized for your machine architecture, and then you deploy it out.
Yeah,
so that's pretty sleek.
So there's a transfer learning toolkit. There are many tools for this task, which are very efficient. And you actually have to remember that you have to take the model, and make it fast for the edge. It's not just taking the model. You have to get it to TensorRT or whatever.
Correct.
And, this is also very, very well defined in the Microsoft solution and very thought of.
I think that once we get into a Wi-Fi 6 5G world, that edge computing is going to die really fast because you'll be able to replace it with thin client computing, and all of this pruning doesn't have to be done anymore. Make your network as deep as you want.
We'll make it. We'll make bigger networks, and let's hope there are no riots over the.
It's kind of funny. There is this 10-year cycle where you go from the edge back to centralized and back to the edge and back and forth.
Back and forth.
So
there's always an insatiable demand. Right. There's always an insatiable demand. We always see as humanity, we always fill up the bandwidth. Right.
Yeah, and video is number one there in the on the bandwidth, but maybe with the augmented reality, virtual reality will be even more. Higher resolution.
So just thinking a little bit more, I'm still curious about the experimental process, but when it comes to sort of jump in, but I'm curious about how you guys personally approach versioning your data sets and your script files and your experiments, because I know with the financial applications we pump through hundreds of unique scripts and permutations on our hyperparameters and things. I just wonder, what are some of the tangible, if someone wants to take away some tangible tools or methodologies to think about versioning their data and their pipelines, what do you guys think about that?
There are actually companies that this is their business, There's Allegro, that some company that is very good at it, just they call it data and the model and the inference and everything. So it's there are many companies that do that. Some of them are also Dockerized on GC. So it's a real business. It's not something that you
just throw together. Yeah. Interesting. Yeah, I know. There are a lot of services. So SageMaker has some. There's Neptune AI. There are a few of these services. So it's definitely a headache that should be organized.
Yeah.
Cool. Okay. At that point, this kind of edges us towards the more specific question, which is, what are some of these little script files or open source libraries or little tools that, what's something that you have a tendency to maybe install right away in a Docker container? You're like, I'm going to use this library right away. And it, obviously maybe something standard like TensorFlow you throw on there, depending on what you're making. But what's something small? You're like, this is a really great tool. I always think of it. One of my favorites is SQLite when I want to move around data, because it's easy. I can pack something up and I can query it really quickly.
Yeah, it's very developed, this world of Docker. You have Docker for everything, for TensorFlow, for anything, for a complete task actually, for BERT.
If you're playing around with computer vision, there's like a 90% chance you're going to end up using Cocoa at some point.
Right.
Which is very open source labeled image set. And then there's ResNet and AlexNet, which are use frameworks.
And
Mascasian.
And I sometimes thought some. Sorry, go ahead.
Andreas, I'm sorry, I didn't mean to interrupt you. You can go ahead. I can speak later on.
Yeah, I typically go back to the basics. I install my basic Python 3.7 or 3.8 in our environment, and then the first thing is install SciPy, NumPy, Pandas, Matplotlib, the basic stack, and scikit-learn. Scikit-learn, scikit-image, and OpenCV for some basic stuff. And scikit-learn has some really nice tools where if you want to train validation and test, it allows you to split the labels and the dataset very conveniently. And you can draw in from SQL, from CSV files from almost any data source there is. It automatically loads ResNet and all the standard data sets if you need them. It's a pretty convenient way to start.
For me personally, what I basically start with is like, first, as I spoke, right, I mean, wherein I understand the use case first. I mean, and majority of my use cases get solved with the services which Azure Cognitive Services offer. So I basically use APIs which Azure Cognitive Services use, like object recognitions or text-to-speech recognition, or like Bing APIs with respects to searching. So I use those APIs to ensure so that I don't reinvent the wheel. I was not an expert in AI from the start, right? So I did not know how to create like machine learning models at the start. So I used these capabilities to give me a head start on my use cases. And then once I started understanding the intricacies and the small things with respects to making the models accurate, I then started, kind of focusing my attention there. I do this wherein, I basically start with the ones which we already have in terms of services, and then basically go and train the model and make it more accurate.
It's a really interesting comment, because I think as a developer, I suffer from this problem as well, where when I first encounter a new challenge, the first thing I think to do is to open up my editor and start coding a solution. And especially in the space of training a model, you want to train your own model on your own data, and that takes eons. But obviously, if you could leverage a service and get yourself halfway there to at least filter your preliminary data set, why not, right?
Yeah. And the design.
Go ahead, sir.
I mean, I just wanted to add like one more comment. So like the only thing to basically follow this is like the design should be modular enough that you can switch your model from like a service to the actual model you add later on for more accuracy. So like the modularity is something taken into consideration before designing the thing, like that's what I want to add. So.
Yeah, no, perfect. Do you want to speak to that at all? So sort of, you're talking about this idea of designing a modular framework or a local development environment that is compatible with several models. That sort of hit back to more specifics on the pipeline idea. So do you have any, what are some of the architectures as a software guy? What are some of the architectures or design patterns you would lean on to develop a clean interface like that?
It again depends on what we are trying to do here, right? I mean, so if let's say, but in generic terms, we should always separate our the data from the pipeline as we're talking about it. We should always try to separate and have like a common data contract when in terms of the AI model basically processing the data, and then like what the user or the outcome is, correct? So that is where the modularity should be achieved, as far as what I try to basically word, wherein I try to separate these two layers off, so that later on, if let's say I'm using this I'm using the services for training the data, later on I can replace it with some model which I work on to build more accuracy. Did I answer your question? Was it?
No, I think that's perfect. It's right on hits the nail on the head. I'm thinking about when you're crafting your Python scripts, let's say, and you're actually worried about what file do I write where do I include this model? How do I make sure it's modular enough? How do I make sure I store my data in the right place? These are some of the questions practical questions you have to answer. So, but yeah, it's interesting. Yeah. Perfect. So we're ahead of schedule a little bit. We have a bit of time where we could entertain some questions amongst ourselves, but we also have quite a few Q&A questions. So if there are, okay. It seems some Q&A. So I think without further, we should jump into that. Madison, is that something that I should be, or are you going to jump into these questions for? Oh, sorry.
I'm writing in the chat, but I can just address you directly that yes, you can continue to moderate. So to select the questions that you think are the most relevant or interesting. It looks like they're being relayed back to you right now. So
okay, I've done a poor job of keeping track in the chat here. Let me see. But I do know, let me scan here. Okay, so I'll just maybe do bottom to top. So here's a question from Slinky Castle. What are the what is the best way to keep track of the future work of the speaker? So if we want to follow your work, for each of you, if you want to take a moment just to say, we're personally interested in you, we want to follow you as much as possible. How do we do that?
Yeah, LinkedIn, I think, is the basis.
Yeah.
Yep. LinkedIn.
I agree.
TikTok,
A little
maybe
slow
TikTok also.
But if anybody,
I'm going to interrupt this one and say I will paste everybody's LinkedIn's into the chat. So let's move on to a different question.
By the way, I was thinking about TikTok, okay?
Yeah, you should. We should all become TikTok stars, right?
TikTok has
I've been really into TikTok.
data set in the world, okay? You talked about analysis and everything.
No, it's not all about LinkedIn these days anymore.
They have the biggest, I think, data set of text, audio, and the facial recognition. Just matching between audio and.
Perfect.
Yeah, but it will become relevant for robotics if someone from TikTok hears this. So, outstanding.
It's true. It's a good data set for sure. So can anyone comment on using AI? I should read the question before I read it out. What if it goes in a strange direction? But can anyone comment on using AI for feature recognition on 3D LiDAR data? So specifically thinking about LiDAR data, specifically which is non-regularly sampled. So, one dimension or 2D images, so data set. I'm trying to think of what that data set would look like. But
yeah, there are models for that. Yeah,
we do synthetic LiDAR as a service where we cross-reference the 3D objects from like the RGB camera and the other annotated views that we have, and then we throw the synthetic LiDAR on top of it to be able to create a really robust training set for those kinds of problems. So if somebody wants to reach out to me afterwards, I'd be happy to chat about that.
Yeah, also Isaac has a sample with 2 LiDARs. Isaac is a framework for training robots, so maybe we can, make it work together with Alexa and get your data into it.
I think in the last 2 years, a lot of open source code for AI data has come out. A lot of them I think focus on the high resolution and high fidelity LiDARs like the Velodyne or Auster Pax, where you really in each frame you get a full 3D scene. So really regularly spaced. Offhand, I don't know anything about where the data is sparse. And that sparse data for that would surely be a problem.
Right. So the next question I have up is, do we have any good ideas for novel hardware products related to AI? So, what is needed? I'm not sure the second part of the question, but what is needed for the next generation of AI products? So, what are some good hardware products that we could dream up, and what are some of the hurdles we might face in doing that?
So there are, of course, excuse me for, I have to answer that because
you're the NVIDIA guy. Go ahead, man.
the Jetson family, okay, it's a set of edge devices. We have the Nano, we have the NX with the Nano Xavier, and there's the Xavier. Of course, there's the TX2. It's a little bit older. So these devices are very, very powerful. Okay, we're talking about 11 teraflops and even more TOPS, which is inference. It's even much more than that. So and these devices have the same framework. You can deploy the same DeepStream, Dockerized DeepStream with Azure IoT from Microsoft. It's really mature. Okay, this family of devices are used in robotics, autonomous machines, everything. So I would recommend on using Jetson, but if you want more information on that, just let me know. The NX was just announced. I think this 1 week or two was announced, and it's very powerful.
Could I add to that question? Actually, I'm a software guy, so I don't have the answer. But from a hardware perspective, it seems like all the hardware is really, for floating points. So it's again for statistical frameworks. But as we make progress with, reinforcement learning and adding more, rule-based systems back in, do you see the hardware evolving and maybe not being so floating point GPU centric?
It's definitely integer. We have the int8, so it's not floating point at all. We have the tensor cores, which actually handle multiple matrix multiplication in the int8 domain.
On chip.
So it's definitely not only TensorFlow, not only float, but by the way, there's also the A100 with the Ampere, which actually speeds up the float calculations. Okay, so this is done by a new data type that was introduced called the TensorFloat, which is a little bit, just played with the mantissa and the exponent, and we got a big speed up with less bits. Okay, so this is something that will come very soon to the Jetson family too. Okay, so this we even, NVIDIA even changes the data type, and this is just shows you that we're data oriented. We're not keeping the hardware as it was for many years. We're changing and evolving throughout this process of AI.
There's a question that piggybacks on that. It's a bit surly, but it says, why is the NVIDIA Jetson still $200 if I buy 10,000? How many million do I have to buy to get a price break?
So you have to need to understand which one you're talking about. And if you have a good case, we're very interested in our developers. We want to help them.
Sure, so you should get in touch. So Endless Clock, you can get in touch and
take the feedbacks and actually modify our SDKs according to the developers. We're constantly in communication on everything.
That's perfect. That's good.
So one thing on the hardware side I've seen is a little bit of diversification into more general purpose machine learning architectures like the NVIDIA Jetsons, which, yes, they're video optimized, but in principle you can feed a lot of data types and a lot of models on them, versus really application and problem specific hardware, right? Where the silicon is designed for the specific neural network you want to run. You can perhaps change the networks out, but the rest of the architecture is basically built into the silicon. And you can do those now, make them in production relatively cheaply, and we can make them really fast with low power consumption. And there is a lot of activity to put machine learning capability on the microchips directly, kind of on IMUs, where the IMU has a machine learning component to wake up the main CPU if certain motion motions are activated, or for audio processing, if it's say a trigger word, in the microchip there is enough ML that it can recognize the trigger words and wake up the main CPU to do the further processing. So that's one of the trends I've seen recently.
Cool. That's perfect. So the next question I got here are, does anyone have any thoughts on testing with concept activation vectors? So, you know, that as a path to explainable AI. So, you know, if you're thinking about testing neural nets, trying to figure out if they're explainable, trying to look at, I'm not super familiar with this concept, so I could use a crash course. But how does this concept
the concept, but at a high level, what I would say is that by synthetic data with a good taxonomy and build that taxonomy into the layers of your neural networks, like, is a good way to control like where you're getting nuance and to segment things out so you don't get cross confusion and misclassification.
Right. Oh, this is a good sort of entry level question, I think, that people might benefit from, because it's nice and meat and potatoes. But it's a nice sort of illustrative example. But how hard would it be to train a model to, say, recognize rats? How many images of rats would you need? How many different kinds of rats would you have to organize? So this is kind of like, obviously depends how good you want your model to be, and you know, but it's kind of a good.
So assuming you had like 5 different kinds of rats, and you could crop the images of each one of those rats in different ways, and you could photograph your rats in like a whole bunch of different lighting conditions and a whole bunch of different backgrounds, maybe you could get by.
Rat photo is the first step, correct?
Yeah, so maybe you could get by with like 5,000 rat photos.
Okay.
Yeah, and maybe ImageNet will, you know, get you to classify it as a cat, and you just use that class. And
yeah, but this is a good point. Like, you could start out with a basic classification data set like ImageNet and try transfer learning from there, and augment with the data sets on the rats you have.
Right. I suppose as well, you could probably try to normalize the conditions it works under. You could focus only on profile shots of rats, for example. You know, which would slim up your data set. And anyway.
Yeah, again, back to what we talked about before. It depends on the lighting and on the camera, the resolution, the noise, everything. So it's the question is not closed.
Yeah, it's like,
you can do some tricks.
Diversity of your photos.
Come again?
It comes down to like what is the diversity of conditions within the photos?
Right, of course. So I guess
again, what are you trying to achieve? And what are you trying to achieve, right? So if you need to be able to recognize a rat that's, you know, 90% occluded by a shed, that's a much harder problem than recognizing, you know, a full rat that's there. So understanding exactly what the goal is also going to influence how many images you need.
Yeah, there's also a trend of infrared, using infrared together. You know, with the COVID, there's also the thermal cameras that becoming also popular.
Definitely. I have a question here, a product question here. So when will the Xavier NX be in the Amazon store, or is there a NVIDIA Canadian store?
So I'm sure I can tell you that there is reseller in Canada, of course. We just have to, you know, you can, you know, send me an email or whatever. I'll get back to you on that. And on Amazon, I don't know when it will get there. Can't tell you.
Perfect. So I have some. So we've pummeled through. If there are any that I've missed, you can feel free to send them to me, Madison, if you can do that. But I have a couple questions that I'm a little curious about. One of them is about process and lifestyle. So when you're as a data scientist, one is related to training and execution. So as a data scientist or as a developer, how much of how much of your time, or how do you schedule, or how do you organize curriculum for yourself to retrain? How do you expose yourself to new problems and new resources versus how much do you focus on executing and building tools and models? So what's that ratio look like, and what do some of those practices look like?
I can speak for myself. I came from a background of working in speech and natural language, and 3 years ago, I knew very little about computer vision. Helped me is actually just diving into Coursera, going on a computer vision and convolutional networks and things like that. So I think it behooves all of us to jump on those kinds. I'm not trying to do a plug here for Coursera necessarily, but I think that it really helps to your real world experience every day with some of these mentioned Udacity. These are really helpful to get your knowledge base up in a relatively short amount of time if you have a commitment to do it.
Yeah, you have also the NVIDIA DLI, Deep Learning Institute, lots of practical courses with actual GPUs running. That's another topic, of course.
Yeah,
that's good to know. So that's very relevant.
I have a little pet project called RoboSteve at MistyWest, and I have a version of that called the Donkey Car privately at home. And that's kind of my practical playground, and kind of I mix MIT as a really good course. I'm actually going back to the basics right now. I'm a mathematician, but my statistics is not where it should be. So I'm retraining my basic statistics and my basic ML from the ground up. And so I try to find a balance between theory and then an application. Meetup is fantastic. There is a great group in Vancouver. So there's a data science reading group which goes through research papers, and the other group goes through Kaggle competition. And I think most major cities has one of these groups. And now with COVID, all of the meetings are online, so it really doesn't matter where you are.
That's great. Here we go. Go ahead.
Yeah, I'm so sorry. My
please.
issue went there. I'm guessing the question is still like respects to how do we the ratio between times, right? I mean, I'm guessing we are still in that topic.
Sorry, repeat it again.
The question, as far as I understood from the thing, is that what's the ratio between what we should
that's still the
focusing on. Yeah. So see, for me, like I was talking about, right? See, I try to create like a platform agnostic model beforehand in terms of designing. So when I say platform agnostic, wherein I use adapters, right, in place to basically ensure I just have to change only that part of the code if my model changes or if I'm training new things, while rest of the other things in my model doesn't change. So that is where like thinking in terms of agnostic platform, that helps me save achieving accuracy at the start, but later on, accuracy for me, like for my projects which I do, is not that important at the start. So for me to create a POC for the use case by using adapters and using agnostics, patterns which use agnostics, helps me to basically focus on the use case first, and then if needed, then I go on the accuracy of the thing.
I have one question for you as well, specifically one step further than that, just because everyone else chimed in on this. So when thinking about your own expertise and skill sets, what are some resources or practices you consider to keep your skills at a certain level? And how much time do you spend worrying about, say, retraining yourself or taking courses, etc.?
That's a really good question. So I mean, we are living in the world wherein things transform like really quickly, and it's like it's like every day there is like a new technology which gets invented in the world, and we can't like train us, we won't be able to achieve. As a part of my, I normally do it. So I mean, it is more towards like a day in a week, which I've basically kind of scheduled for myself to basically kind of pick up those trainings and pick up on those aspects which are coming up.
Okay,
I mean,
perfect.
I hope like there's a. I mean, if anybody wants to add to this, I mean.
Oh no, we were all selfishly, we got to all chime in on it. Well, so we're all the same together. So perfect. So on the COVID, what's some of the progress you feel that's being made on tracking air travel passengers using vision? We could take technology, considering technology such as temperature.
One of the projects which are working on in Microsoft. So we are basically trying to kind of. So the problem is like for COVID-19, right? I mean, 88% of people who are basically contracting COVID-19 have fever. So and the problem is like when they go to hospitals, right? So like when they're standing in the lines, it's very difficult for a particular person to understand whether a particular person has COVID-19 or not. So the early detection is very necessary so that the outbreaks don't happen in those lines, basically. So that is where we are trying to kind of use it, like at least the 88%, and kind of detect those people early on using thermal sensors, and like kind of using AI and like using thermal sensors to detect whether the temperature is coming from a person or it's coming from an object. And we're using it through Azure Cognitive Services people recognition APIs as well as object recognition APIs. And we basically are kind of trying to kind of filter those out so that we can like partition those people into a different subset, right? Who have a higher temperature and then can be tested and like maintain social distance and monitoring and things like those so that the outbreaks don't happen. So that is one of the areas which we are focusing on right now.
Okay, interesting.
Yeah, there are many solutions for COVID. It's called COVID. So for social distancing and temperature measuring, mask, no mask. I don't want to say it's a buzz. I hope it will go away, but I think we'll stay with some of it. So some of this technology will stay, of course, and so we rest thing.
So the interesting thing is, I think the airports already had most of that in place, and they're doing temperature scanning for a long time, and they had the FLIR temperature cameras at their gates for a very long time. So they were ready for that. And from what I've heard in almost every place in the world, the airports have been very successful in tracking. And the disease came in through other vectors. Where it has moved to is move this technology into other places. And there it's a lot more difficult to apply because you don't have to wait in the gates. It's not as controlled an environment as an airport is. Not to mention privacy and other things associated with that.
Exactly. Speaking of that, actually, that's a really good segue, unless anyone has more COVID comments. No. So speaking of privacy and the subject of malicious users, and thinking about the taped over stop sign earlier in the computer vision problem, and I mean, there are loads of ways to spoof computer vision problems. There's even take an image and fake it for any neural network and have it look identical to a person. So what are some approaches that you might, and some use cases that you may have considered when considering potentially malicious users who might want to circumvent detection or, identification of objects or themselves, etc.? Is that even something that you consider in your data sets or pipelines?
So something I've thought about, but not for a bit more broadly speaking, is I think we're going to see the beginning of data warfare in the not so distant future if it's not already happening. And it's pretty easy from an AI standpoint to think about how that would go. You get a bunch of artificially labeled data that's not the right data, and you find a way to slip it into somebody else's data set. And so you could pollute a data set very quickly and really mess up an AI by doing that. I'm sure it has and will happen.
Definitely. I mean, I know with financial data, we inject a ton of noise and a ton of anomalies. Wrong data, price drops, all sorts of things to try to, because anomalies or misreportings of statistics, in data happens all the time. Do you guys approach that with computer vision as well? Like, will you inject weird data into your pipelines?
Yes, you do.
Yeah.
You can even try
I can. Sorry.
Right, go.
Okay, I was just gonna. Sorry, we're all speaking at the same time. So hard over online. I was just gonna say that there's government funding around detecting deep fakes for obvious reasons. Yeah. And so SRI is part of the hunt, and we're actually looking at not just visual but audio and synchronization between audio and visual, and applying some deep learning techniques to that. So that's a really important area for the future, obviously, and the U.S. government, probably among others, are funding these kinds of efforts to be able to detect them.
But yeah, generally, when it comes to computer vision data sets, vision data sets are kind of fragile when it comes to like what happens when anomalies get in them. Like the accuracy just falls off real fast, and so I mean, like they are vulnerable in that regard.
Yeah.
You can measure this somehow.
Multiple cameras. This is the simplest thing to be able to overcome that is just add another camera. You'll get a better statistic, but add a LiDAR, add depth sensor, you can get better.
And review your data set, right? So that's one of the things too, is you don't just accept the data set what it is, but if there are truly outliers that shouldn't be there, you throw them out, or you start learning that they aren't outliers, but simply things that happen less often than the normal case.
Yeah, I mean, you could write visual search parsing agents to go through your data set and look for anomalies.
Right. I wonder if you could use the what's the technique where I'm blanking on the name of this technique. You could use adversarial networks, perhaps in some sense, to try to generate fakes from each other. Yeah. So that would be GANs. Yeah. To some extent, like I don't think GANs are supposed to try to be so malicious as to come up with like absolute crazy examples, but that seems to be within this sort of family of challenges.
What the artificial generation of adversarial images, what they typically come up with is single pixel variations of the image which 100%. Will completely misclassify. So as far as the outlier detector is concerned, these images that are identical, yet it throws the classification off completely. And there are some, specifically have model access, you can actually construct a set of adversarial images and you can add them to your training set. The problem when you do that, you reduce your overall accuracy. So there is nothing for free, right?
Yeah. Okay. So thinking more on HR level. So if you're considering working with either a new grad or even someone, probably equivalently these days, someone who's been around for more than 3 or 4 years, how do you figure out if someone's the right fit for an AI team? And how do you vet a professional? What sort of characteristics do you look for in someone to work with?
I mean, I guess it's use case specific. I mean, at Lexset, we get hyper concerned that somebody has 3D experience in addition to AI experience, because we have found that people who are not used to thinking in 3D really struggle with it. And so, we'd like to see some linear algebra, maybe some VFX in their past. But that's because we're really dealing with 3D AI, which is different than 2D AI.
Right. Interesting. Okay, cool. Any thoughts on
so in addition to looking for specifics, if we look for specific jobs, I like critical thinking. And I typically don't like the answer like, oh, what do you do in this case? And if the answer is, oh, just throw AI at it. I typically would like a logical thought and a critical breakdown of a problem. And that includes going back to the basics. When you give me labeled data, the first step isn't to look at the mean and the variations and the distribution of your labels. The interview is basically over.
I also want to add to this, I totally agree with Andreas, and also with respects to passion, right? I mean, if a particular person doesn't have the passion for this particular domain, then it becomes after some time, just because it is hot, after some time, it becomes I've seen that, people start getting bored of it, and then they just try to move on, or they get stuck. So I feel like, if you have like a true passion as well, would definitely, kind of, help you with this particular domain.
So my favorite, yeah, go ahead.
I just want to tease off of something Andreas said about critical thinking. So I would, when I look for researchers to work on my projects, sometimes I want to make sure that they don't see that every nail can be driven with a DNN hammer, right? So sometimes there are simpler approaches to solving some parts of the problem, that not everything lends itself to a DNN solution. So having that kind of critical skill to say, oh, even though this isn't my domain, maybe here just a linear algebra will work just fine, and not a DNN approach.
Yeah, it's a thresholding problem.
Yeah. I want to slip this question in actually on that note for myself, but I spend a disproportionate amount of my time designing features and using my own instincts, to look at data, to look at strange patterns, to come up with human features, which then get passed on to be part of training sets. And computer vision, to what extent is that? I know you pre-process videos and take care of your data set, but to what extent are you using your own inspiration to try to create interesting, weird features? I'll multiply things put things through strange transformations. Like, how much of that is part of the pipeline of the process?
Tons. Like, that's what all of the papers are about, or it's some interesting flavor of like feature extraction. Maybe they're like flipping the images backwards, and then they're taking like random like camouflage style patterns out of the image. Like sometimes they're like doing all kinds, like they're using like every Photoshop trick in the book. Yeah, exactly. Like,
yeah.
You play with the exposure levels, you play with the color balance levels, the hues, you invert it. Like if you can do it in Photoshop, you should do it to your data.
Yeah, and like coming back to actually what color space do you operate in? Do you go from RGB to HSV? Is intensity important versus the true color? What kind of lens, what kind of colors do you actually have to begin with? Can you modify your wavelength in a way that you're interested in specifically that wavelength? We're back to physics, right? But
yeah. So I have my own. I'm going to keep a couple questions loaded, but I have to get through these. But this is a really the subject of feature engineering is very interesting to me personally. So this is a Marvel fan question. Is the name Jarvis based off of Tony Stark's AI? Cool. That's great. Okay, okay. So let's see here. All right. Okay, so yeah, so perfect. So I think at this point, am I correct in saying we should be moving into sort of closing remarks? Is that correct? Okay, perfect. So yeah, we're at this portion where we've had that apparently it's time to stop talking, which is very sad. But if you guys had anything you would want to share to sort of round out your project, your approach, or if you want to give a shout out or ask for any input, this would definitely be the time to do this. Maybe we can. I'll just run through the from top to bottom. So Andreas, do you have any comments you'd like to leave everyone?
Well, thank you for everyone on the panel. It was a lot of fun to talk with all of you. Haven't done a panel discussion in a while, so it was good to get back into the game. I really like the topic. Stay in contact. LinkedIn is probably the best and most convenient way to do that. MistyWest, we're doing events like this at least every 3 months. So check out our webpage and come to the next event. And I'm going to be a bit more active on LinkedIn and posting the ML projects I'm currently doing. We actually just submitted a proposal to MIT Solve today, this morning. So I'm going to be posting a lot about that.
Okay, and by the way, Andreas, if you want, to ask questions about Jetson, anything, support with Deep
have any sort of closing remarks for the company?
Yeah, no, I really want to thank everyone of, which we like everyone in the panel. It was very interesting topics which we have discussed, and I got a lot of different perspectives which I did not even think about when before coming into this meeting. And I really love the diverse perspectives which we had from everyone in the panel. And I really thank everyone for the opportunity here. So thank you.
Thank you very much.
Perfect. Ayel, how about yourself?
Yeah, actually, it was very much fun, to meet you all. I guess we'll have a continuous discussion. Also, Alexa sounds very interesting, and we can continue this. Not just doing this session and that's it. Continue discussion. I think we have a lot to talk about.
Definitely. Edgar, how about yourself?
Yeah, I want to say it was a great panel discussion. I love these things because I feel like I learned something. I definitely learned a lot today from my co-panelists. So those out there in the audience, to use a metaphor of American football, we're on the 1 yard line, maybe the 5 yard line. We still have a whole huge, rich field ahead in computer vision and robotics. So. This is a great time to be part of this effort. I think it's going to be transformational over the next decade or decade and a half. Thank you for having me.
And Les, take it away.
Yeah, this was so much fun. Let me echo the sentiments to all the fellow panelists. This was, just a blast talking with you guys and learning from each other. Thank you to MistyWest for hosting this event and to Microsoft for hosting this event. Like, really cool of everybody to make this happen. And then let me put on my sales hat and say that if you have data needs for your computer vision project and you have a sense that might be able to be solved with synthetic data, please reach out to me and let Lexet take a swing at your project.
Perfect. Yeah, good pitch.
We had a couple of questions for Ritesh. Do you have any contacts or LinkedIn information to share? Because there were some requests for it in the live chat.
Sure, I will send that to you, Madison. Yeah. Should I send it to you right now in the chat?
Yeah, and then we can paste it into the live chat.
Sure.
Perfect. No, same for myself. Thank you to MistyWest for inviting me to moderate. And I don't know too much about computer vision. I'm more of a multi-agent RL guy. So if anyone ever wants to nerd out about reinforcement learning or data visualization, these are some of my core interests, and I'm always around. So yeah, thank you so much.
All right, thanks, Justin. I have some closing slides here. Just before we have everybody drop off the call, we have like a couple announcements for everybody to just get, and a couple thank yous. So just hang in there. All right. All right, so I want to thank MistyWest, as everybody mentioned, for putting this together. We have been organizing these events for quite a few years now, and I'd say that we've definitely been getting more into our groove in the last year and a half. These online events so far, we've only done 2, but they are turning out pretty well attended, essentially better attended than our in-person ones. And we want to give a huge thank you to Microsoft, specifically Microsoft Garage. You cannot see them, but we have 2 moderators behind the scenes. We have Chris Richards, who is also a former Westie, and they've been moderating and dealing with all our ongoing technical difficulties throughout this. So we want to give them a huge shout out, because without them, we might have just had to drop off within like 30 minutes into the event. And I want to give a thank you like a couple of quick little announcements, and if any of the panelists have anything to share as well. And I also just completely forgot to introduce myself at the beginning of this event, but my name is Madison and I am the organizer of the Vancouver Hardware Meet, also the content creator and community manager for MistyWest. Like what ideas you have, because now that we've been working in an online, it's making it a lot easier to put these events together. And a couple of quick announcements here. One important one is that we are hiring right now at MistyWest. We're looking for an intermediate mechatronics engineer. We have a careers page, and you can learn a little bit more about what a career at MistyWest is like.
We have the Isaac simulator that allows you to simulate also the material physics and the actual robot. You can take a robot spec with the physics and put it in a simulated environment, and then it can real-time ray tracing data, and very even design the camera. We talked about cameras. You can actually design an optical sensor and put it in as part of the training. I will not talk too much about this, but this is a new features on the Isaac SDK. It's available. So if we're talking about robotics, I think this is a good way to start. And actually, there is a spec of several robots that you can take and reproduce several use cases of these robots. This one is Cartel. The name of this one is Cartel, if you're interested. So again, you can send me questions.
Thank you. That concludes the hardware meetup. I want to also thank Justin for moderating. I just didn't get a slide in to directly acknowledge him, but I really appreciate the work he did, even though there was a couple behind the scenes moments where I was giving him a hard time. But he did a great job. Everybody that was involved today did a great job. And thank you so much to everybody that tuned in and follow us on Twitter, on Facebook, or LinkedIn. And we also have a meetup group for the Vancouver hardware meetups. I can post that into the live chat, and please join. There's over 1,300 members, so that's where you'll usually get the first information about our future events. I want to thank you so much.
It's perfect.
Have a nice one.
All right, thank you.
Thank you so much.